in the screen. This one, lecture sheet 10. We already started lecture sheet 10. We already solved some problem, right? 2, 3 problem. And this stuff is already finished. And this problem, we already solved it. Number 3. 3, 2, 1 already solved. We solved this 2, 2. Now you need to know just some basic about the real fluid, about the pipe, and there is some fact in the fluid system. Like we use one word is called water hammer. So what is the water hammer? How we can protect or you can remove the water hammer? Those kind of things we will discuss. And also there is a lot of type of valve used in the fluid system. So this last portion of this chapter is very important. Say after graduation, you got job in gas field. They have a lot of pipeline with different type of fittings. So as a graduate from the mechanical department, you should know, you hold a fitting, you know what is that, you can tell the name of the fitting immediately. So those the pipe fitting, then we have some bulb over here. You see different type of bulb they used in the pipeline. So those kind of things we will discuss and hope we are able to finish it within one lecture. Okay, so let's see. Number one thing, pipe in series. Pipe in series means in the same pipeline, sometime you might have different diameter of pipe, but they are connected in series. If you have one pipe, it has certain diameter, then you add one more pipe with the same line with higher diameter, then your diameter might be even reduced. Okay. So all the segment have different length, like this is L1, and same amount of fluid is going through the different section. If this is Q1, this will be also Q2, this is Q3. So all the Q has to be same because same amount of fluid passing through the segment of the pipe. Now, if you have different section, there will be some frictional loss, right? So those frictional loss is not the same because diameter is same. Because velocity to different segment of the pipe is not the same. For example, 1 second, diameter over here B1. I'm sorry, velocity B1, and over here velocity B2. Because what is the Q? V equal to Q by A, right? So if cross section vary, then V will be vary. So V is different in different section. And what is the LF? LF equal to FL B square by 2 GD. D is the diameter of the pipe. So you see V is different in different section. That's why the ACLF, that means frictional head loss, is not same in different section. But if you like to figure out the total head loss from here to here, will be summation of all head loss in the wall section. Okay. So if two pipe in series, then you need to apply this formula. It's same thing. For example, you have several electrical resistance in series. What will be the resultant? Resultant R will be like R1, R2, R3, right? So same thing in the fluid. And if you study, there is one course is called fluidics or fluid power control. This frictional loss in the flow, they represent like R1, R2, R3, like electrical resistance. Okay. And the other term we'll use When pipe is parallel, then what will be happen? Same thing as a electrical, uh, like you have three resistance in parallel. So in that case, say the parallel. So in that case, your I passing through right over here, then this will be I1, this will be I2, this will be I3. So I equal to I1 plus I2 plus I3. So similarly, if pipe is parallel, then Q is coming over here. Then it flow is divided into different segment of the pipe, right? Q1, Q2, Q3, then getting out Q. So Q equal to Q1 plus Q2 plus Q3. And you look over here, what is the voltage between right over here? These 2 points. Voltage between 2 points will be same as voltage between this point and this point. If you take measure voltage over here, it will be same. So if two pipe in parallel, then frictional head loss in this segment, and this segment will be same. So ACLF equal to ACLF1 equal to ACLF2 plus ACLF3. This is called pipe in parallel. Now, other term we use is called water hammer. So what is water hammer? And water hammer, it is also known as, sometimes it is called fluid hammer. Different books, they use different term. So it is a pressure surge. Pressure surge means certainly increase of pressure or pressure wave caused when fluid, usually a liquid or sometimes also a gas in motion, is forced to stop or change direction. Forced to stop, what does it mean? That means your momentum is changing. Say you are driving your bike at certain speed, suddenly you make a hard brake. So your sense of momentum is very high because final momentum is zero, velocity zero. Initial momentum m into b. What is the sense? mb, right? So if you change the direction of the fluid or suddenly you stop the fluid in a flow, then there will be increase of pressure. For example, you have a pipeline in a fluid system and say over here is going in the tank. In the tank, right over is a gate. And fluid is coming with certain pressure and velocity, but suddenly stop the gate. Then what will happen, right? This region, pressure will increase immediately. So if pressure is increased immediately, then this pipe might be vibrate or it might be collapse. Okay. Okay, could you hold down? So what I like to say, in fluid flow, in a fluid system, if you stop a valve in certain location within very few moments, then there will be increase of pressure. That also is called water hammer, and or it is also called fluid hammer. Okay, and water hammer commonly occur when a valve closes suddenly at an end of a pipeline or fluid system. That I already discussed. It's saying a pressure wave propagate in the pipe. It also called hydraulic shock. So you see, it has a three term: hydraulic shock, fluid hammer, or pressure hammer. This pressure wave can cause major problem from noise, vibration, and to collapse of the pipe. So it is possible to reduce the effect of water hammer. And now, why you need to protect it? you need to make sure that in the fluid system there is no water hammer. We say this is pipeline, and you are sending by a pump right over here fluid in certain tank. Okay, and right over is a valve. So what happens? Say for example, you are seeing that immediately there is an explosion in the tank, or there is a fire in the tank, or there is a leakage. So you need to close this valve immediately. So your pump might be 2 miles away, might be 400 feet from your location, this valve, or you might be controlling from your control room. Electronically, you are managing your fluid system. So you give command to close this valve. This pump still far away from this valve. So you cannot give two commands at the same time. It takes some time. And even you immediately close this pump, but still some fluid will coming out for a certain time, right? So this fluid, if you stop this valve immediately, it will cause the vibration, it will cause noise, and your pipe might be collapse. So if pipe collapse, then there will be more leakage and it will deteriorate with your tank leakage. For example, you working with a chemical industry, they make some sulfuric acid, or you working with a liquid nitrogen, liquid oxygen, or working with crude oil, so or natural gas. So everything sometime you might working in a nuclear power plant. So those sensitive area, you have to make sure that there is no water hammer or fluid hammer will happen if you close a valve suddenly. So how you can close it, or you can minimize this water hammer. So it is possible to reduce the effect of water hammer by incorporating. You need to add some system in the fluid. Number one thing is accumulator, expansion tank, surge tank, and other feature in the fluid system. You need to add those systems, and you can minimize the water hammer. So let's look at the diagram. You see the figure over here. This figure you see is right over here is a turbine at the bottom, right over here, this turbine. Okay, so water coming from the reservoir. Say they are not showing the bulb over here. Say there is a bulb. If you close certain valve, say this tank is not here, then what will happen? In this pipe, pressure will increase, and suddenly this system will break down. So if you add a reservoir at front of this your gate, it's called surge tank, or sometimes it's called accumulator. Then what will happen? If stop this valve immediately, the fluid from the reservoir will go to the surge tank. So there is no increase of pressure in this region. So this way you can minimize the water hammer, okay, or control the water hammer. Something right over here you see, this is expansion tank. Say suddenly you close this valve, shut down, so fluid will not go to the tank. Okay, so in that case the remaining fluid will enter in this tank, or is a fluid is coming out from the tank, and you close this valve suddenly. So you close this valve, then what will happen? Remaining fluid will enter in this tank. Similarly, this one is called accumulator. Okay, so by adding accumulator or expansion tank or surge tank in the fluid system, you can minimize the water hammer. Okay. Now there is a certain type of valve, outside not valve, pipe fitting that normally we use. Sometimes you working in your house or you living in a flat, you will see a lot of fittings in the pipeline, but those are simple fitting. But in chemical industry, you will see a lot of complex fitting in the pipe system. So this one, like elbow 90 degree, this is called T joint or T fitting. Then you see red T fitting. Red T fitting, this is high diameter, this is low diameter. Then you see elbow, cross fitting. Right over here is Y fitting, you know. So a lot of fitting is there. So you just go through through this slide and try to remember this name of the fittings. At least you join sometime, say you are going for interview in a power plant. They might put some fittings in the table. They say, please tell me the name of this pipe fittings. So that is the purpose to put in the slide. And sometimes I put a question that and give name of 5 fittings, commonly used 5 fittings of pipe fittings, or give name of 5 bulbs used in commonly used. Okay. So you see, this is called reducing T, elbow, flange. This is called cap. For closing, this is called coupling. Same diameter pipe, if you like to join together, you can use the coupling. Then if they have union, then male union, then male elbow, female elbow. So a lot of things there. Okay, now we go through the bulb. What is the bulb? It's a bulb is a device that regulates, control, or direction of flow of a fluid by opening, closing partially, obstructing the fluid flow. That means purpose of the bulb is to control the flow. So sometimes we're using in our pipeline in our home, right? Using actually you open the tap, that means there's a certain bulb. You close the bulb, water will not flow. You open it, water will flow. That means you are controlling the flow rate. So type of the bulb are used in the fluid system depend on the requirement and also what type of fluid, what type of controlling you want. Okay, still you see some bulb, they leaking water. So even you buy a new water tap from the market, plastic or steel, if they are not good, sometimes you might see still they are leaking water drop by drop. Okay, each drop. And so depending on the requirement, you will choose your bulb. Cost of the bulb in the piping system, about 20 to 30% of the overall cost of the pipe. Just is a thumb rule that this much might be cost of the bulb, 30 to 20% of the total cost of the piping system. And what are the type of the bulb? There are several types. I just put some common name. Number one is gate bulb, then globe bulb, check bulb, glass bulb, ball bulb, butterfly bulb, is a needle bulb, pinch bulb, then it has a pressure relief bulb. Okay. Now how they look like. Okay. So this one is called ball bulb. Okay. And this one is globe bulb. You see right over here, you just push down, you sit down right over here, it will be closed. And this ball bulb, it is rotate. By rotation, it just close your flow, because it is a hole. If you keep this way, it will not flow the water. But if you rotate 90 degrees, some rotation, water will flow through the hole. Then this is called butterfly, normally used in the automobile throttle body, like a plate. Is rotated, this plate is rotated, then bulb will be open. This is called needle bulb. Then it is called poppet bulb. And right over here, cock or plug bulb. Okay, plug bulb. Then you see spool bulb over here. So a lot of types of, but the spool bulb, if you move this one toward right, then what happen? This one will sit over here, and this one will sit just over here, and there will be no flow from this port to this port. This is called spool bulb. in hydraulic control system, normally they use a lot of spool valve. Okay, this is schematic diagram, but right over here you will see some real diagram. If you travel in the Mirpur 10, you look in the overbridge in the left hand side, in the east side, you see there is a station, the control of the gas supply. And if you look carefully, you will see a lot of bulb is there. Also, densitymeter is there, if you look carefully. So this is a type of a gate bulb. This is globe bulb. Then you see ball bulb over here. And this type of ball bulb you will see sometime if you look to your water tank area, you see in the pipeline they use this type of bulb. Just you move 90 degree, bulb will open and close. And then plug bulb, diaphragm bulb, sec bulb, needle bulb. Okay, what is the sec bulb? Sec bulb, if you see the tube, they use sec bulb. That means it allow the flow only one direction. It don't allow the flow in other direction. That is called sec bulb. And there is needle bulb and pressure relief bulb. What is the pressure relief bulb? If you attach to the boiler, a boiler pressure is getting too high, higher than certain amount, then this bulb will be open and your high pressure steam will get out from the boiler to reduce the pressure. Okay, that is called pressure relief bulb. So this is some diagram, just you just look at it. Okay, and here is the some question I put it, and you should go through those question and you are able to know that what type of question might be in the exam. So far this much from part A of my part of fluid mechanics, So other part will be taken by Shoshi sir. So do you have any comment? Any comment or any question? Anyone?
Sir, can you explain the water hammer again?
Water hammer. Okay, water hammer. If you close a valve, certainly, say you are working in a fertilizer factory and they use liquid nitrogen, and you are supplying liquid nitrogen from tank A to tank B, and it has a certain distance. Let me pull out the presentation. You can see the slide, right?
Yes, sir.
Okay, 1 second. Say right over here, you have a tank over here. Okay, so obviously there will be bulb. If your tank is full, then what you will do? You need to close this bulb, right, to stop the flow. Okay, and over here is a pump, or there might be a tank over here. From the tank, fluid is going to this pump and then flowing directly to this tank B. This is tank A. So in that configuration, what will happen? If you suddenly sometime accident happen, okay, you will see suddenly this one explode, or you say from this tank fluid is flowing in other tank. So right over here you have a caught fire or explosion. So you need to turn off this bulb, and you turn off, right? So what will happen then? The pump is still open, so pressure fluid will still coming toward the bulb. So then pressure in this pipeline will increase. Why? Because there, when came in over here, there is no velocity of the water, right? Because he has to stop. So kinetic energy will be converted into pressure energy as per Bernoulli's equation. So pressure will be certainly increase. If pressure increase right over here, then fluid still coming, he is not able to flow, then pressure will increase right over here. then still fluid coming, pressure will increase right over here. Still fluid coming, he'll stop by the, because this region is high pressure, this region low pressure. When he stop over here, again pressure will increase. So that means this pressure wave, pressure will propagate from this valve to gradually along this direction. And ultimately, there will be vibration in the pipeline and pipeline will be collapsed. Okay. Now, how we can minimize it? That's why if you add the extra reservoir right over here, or it's called accumulator, say this much height, you have connected pipe E and there is a valve over here. So what happened? You suddenly close this valve, then fluid is still coming, then fluid will not able to pass through the valve, then he will flow toward this tank. And all the fluid will accumulate it, Bangla, Joma hawa, will deposit it right in the tank, right? And manually you'll get the time to shut down your pump. So this is called water hammer. That if you stop the flow or if you change the direction of a fluid in a certain location, there will be certain increase of pressure, which is called water hammer or fluid hammer. And what is the effect of it? It causes noise and vibration, and it might be collapse of pipeline or breakdown of the pipeline. And how we can minimize it? You can add extra reservoir, that is called accumulator or surge tank or expansion tank. You can add with the fluid system. Is clear?
Yes, sir.
Like over here, this is called surge tank. This one. If you look in the other system, this is expansion tank, this is the accumulator tank. You know, when it is heavier in case of liquid flow, because liquid is incompressible, but gas is compressible. Say you are closing certain valve, then fluid will still coming, but he has the property of compressibility, right? So he will compress. But if you are working with the liquid, then water hammer will be heavier than the working with the gases. You got the answer?
Yes, sir.
Okay, anyone? Any question? Anyone? No question?